Okay, so 10 pi over 3 inches is the actual answer. Thank you, Jamie, so much. Okay, so hopefully it's getting a little bit clearer for some of you guys who are confused. So again, we need the central angle and we need the radius. And remember, the central angle and the minor arc are the same degree measurement. Okay, so here's, there are a few theorems that you guys need to know. So the chords and arcs theorem. In a circle, or in congruent circles, the arcs of congruent chords are congruent. So if you look at chord RS and chord DF, okay, you can see that they're congruent. They both have the 1 hash mark there. So RS and DF are congruent. That means that arc RS and arc DF are also congruent. Okay, so if you have 2 congruent chords, then the 2 arcs that are formed are also congruent. Okay, and then the converse of the chords and arcs theorem is just reversing it. In a circle, the chords are congruent if the arcs are congruent. So let's say you're given a picture with just the arcs showing that they're congruent, then you also know that those 2 chords are congruent as well. So that's the converse. Okay, so the measure of arc RS is 55 degrees. So arc RS is 55 degrees. What is the measure of arc DF? Okay, so you guys can choose A, B, C for this one. What is the measure of arc DF? And you can see that these 2 chords are congruent. Chord RS and chord DF are congruent to each other. So if arc RS is 55 degrees, what is arc DF? Okay, choose your answer, A, B, or C. Okay, and this refers to the chords and arcs theorem. If you have 2 congruent chords, then your arcs are also congruent. Okay, so if we have 2 congruent chords, and the arc is 55 degrees, what is the other arc? Okay, there's still a bunch of you guys not participating. For those of you who are, you chose B as your answer, and that is correct. 55 degrees. Right? These 2 arcs are congruent as well. So nice job, those of you guys who chose B. 55 degrees is the answer. Okay, in a circle or in congruent circles, the arcs of blank are congruent. The arcs of blank are congruent. Yes, Aisha, then the lengths would also be congruent. That's correct. So if the degree measurements are, those chords are, then the arc length would also be congruent. So A, B, C, or D for this one. In a circle, in a circle or in congruent circles, the arcs of blank are congruent. Is it corresponding chords, congruent chords, continuous chords, or complementary chords? Okay, so in this one, congruent chords. Okay, so I'm seeing a lot of B's, but I'm seeing a mix. Some of you guys chose A. It's congruent chords. So if the chords are congruent, so like in this picture here, chord RS and chord DF are congruent, that means that the arcs that are formed are also congruent, arc RS and arc DF. So for this one, if there's congruent chords, then the arcs are congruent as well. Okay, lesson 4.03. A tangent to a circle is a line that lies in the plane of the circle and that intersects the circle in exactly one point of tangency. Okay, so if you look at this line right here, so line D, it is intersecting the circle at one point, and point D is the point of tangency. It's where our tangent line intersects our circle. Okay, a secant intersects a circle at 2 points. So it's a line that lies in the plane of a circle and it intersects the circle at 2 points. So you can see right here, point D and point C is where this secant line is intersecting our circle. So a tangent line intersects at 1 point and a secant line intersects at 2 points. Okay, which relationship does each line or line segment have to circle C? I'm going to give whiteboard privilege here. To everyone. And if you guys want to write what the relationship is of each line to the circle, so line DE is this line. Is it a chord? Is it a tangent? Is it a secant? Line BC is this line right here. Line BD is right here. Line AC and segment BD. Okay, I'm seeing good answers here. Line DE is a tangent, right? Line DE, it intersects the circle at 1 point. The point of tangency is right here at point D. So nice job, you guys who put tangent. Line BC, also a tangent. Okay, intersects the circle at 1 point right here. That point of tangency is point B. Line BD, you can see intersects the circle in 2 points. It intersects the circle at point B, and it intersects the circle at point D. So that is a secant. Okay. Line AC is also a secant because it's intersecting the point at 2 points. So it wouldn't be a tangent because line AC is intersecting the point right here, the circle right there, and it's intersecting the circle right here. So line AC is a tangent. I mean, is a secant. Sorry, I keep saying the wrong one. Line AC is a secant because it intersects twice. So line AC here should be a secant, not a tangent. And then segment BD. Segment BD is a chord. Its endpoints are on the circle. It is a chord. Line BD, on the other hand, is a secant. So the difference is if they say a chord, that means there's endpoints, right? And the endpoints are on the circle. That's a chord. Line BD is a secant. It intersects the circle at two different points, and then it extends on forever in both directions. Okay? So secants intersect the circle at 1 point. I'm sorry, I just said it wrong again. Oh, tangents intersect the circle at 1 point. Secant intersect the circle at 2 points, and a chord, both its endpoints are on the circle. Okay, the tangent theorem. A line that is tangent to a circle is perpendicular to the radius. So at that point of tangency, where that radius intersects with the tangent, it's perpendicular, so it forms 90-degree angles. Okay? And then the converse of the tangent theorem, a line that is perpendicular to a radius of a circle at its endpoint is a tangent to the circle. Okay, so the radius and the tangent are perpendicular to each other. So they form 90-degree angles. Okay, if line AD right here, is a tangent to circle B at point C. So they're telling us point C is the point of tangency. And they're telling us that the measure of angle ABC, which is right there, is 55 degrees. Okay, so the measure of angle ABC is 55 degrees. What is the measure of angle BCA? What's that angle right there? And let's look back at the tangent theorem. The point of tangency, where the radius and the tangent intersect, they're perpendicular to each other. So 90-degree angles are formed. So what would be angle BCA, which is this angle right here? This is where the tangent and the radius intersect. You don't even need this information. This is just added information, probably to try to throw you off, but you don't even need to know what that is. You can figure out what angle BCA is by just telling you that line AD is tangent to circle B at point C. That's the only information you need to figure out what angle BCA is. Okay, so I don't see too many answers. I just see 9 answers so far. So remember, the tangent line and the radius are perpendicular to each other at that point of tangency. Point C is that point of tangency. This is where the radius and the tangent line intersect. They're perpendicular to each other. So what would angle BCA be? Okay, and the answer here, I'm seeing mixed answers, but it looks like most of you guys have the correct answer. The correct answer is 90 degrees. If they're perpendicular to each other, the radius and the tangent are perpendicular to each other at point C, at that point of tangency, this is a 90-degree angle. Okay. They gave us that this angle was 55 degrees. We would need to know that if we wanted to know angle BAC. So that last angle in this triangle that was formed, which is going to be the next question. So if line AD is tangent to circle B at point C, and the measure of ABC is 55 degrees, what is the measure of BCA? Oh, that's the one we just did. Sorry, I was just showing you the answer. So here it is again. Line AD is tangent to circle B at point C, and ABC is 40 degrees. What is the measure of BAC? Anyone want to do this one on the board? Jacqueline, okay. Let me give you whiteboard privilege. Go ahead. Great job, Jackie. The answer is 50 degrees. Okay, so Jackie remembered that this angle right here is 90 degrees because the tangent and the radius are perpendicular to each other. So we have a 40-degree angle, we have a 90-degree angle. So we're finding that last angle in the triangle. Every triangle adds up to 90 degrees, the sum of the interior angles. So 40 and 90 is 130, and then 180 minus 130 is 50. So 50 degrees. So nice job, all of you guys. We got 50, and thank you, Jackie. Okay, so we don't have time for this, but I'll put the link in the chat box. It was just to review the Pythagorean theorem because you're going to use that in some of the problems for this next lesson. So you guys, on your own time, if you want to just get some practice with Pythagorean theorem, you guys can go to this site and play that game. Okay, so the radius and chord theorem. A radius that is perpendicular to a chord of a circle bisects the chord. So here's the radius right here, and we have a chord. If the radius and the chord are perpendicular to each other, the radius also bisects the chord. Okay, so now this chord is cut into 2 equal halves. Okay, so the radius is perpendicular as well as a bisector. It's a perpendicular bisector for the chord. So in the figure, A is the center of the circle and BC equals 12. Okay, so from B to C is 12. What is DC? Now this is why we need the Pythagorean theorem. The radius and the chord are perpendicular to each other. We can see that right there by that 90-degree angle. So that means that the chord is cut in half, 6 and 6, and they're telling us that this radius is also 6. So if we look at this triangle, we're missing DC, right? There's a right triangle there. We can use the Pythagorean theorem to figure out what DC is. Now I'm just going to draw the triangle out over here so it's easier to visualize. Okay, so here's my 90-degree angle. I'm going to draw that in. This is point A, this is point D, this is C. We know that this side AC is 6. We know that DA is 6. We are missing the hypotenuse of this triangle. Okay. Anyone want to do this on the board? Any volunteers for this one? Okay, Jamie. So doing the Pythagorean theorem. Oh, I think I just took your whiteboard away. There you go. Awesome. Great job, Jamie. So C equals 8.5. So side DC is 8.5. Okay. So notice we have the Pythagorean theorem here, a squared plus b squared equals c squared. Both legs are 6, so 6 squared plus 6 squared is 36 plus 36, which is 72. And then the last step of the Pythagorean theorem is always to take the square root, so 8.5. Nice job, Jimmy. Okay, we could probably get through one more of this, and this was the last thing to go over anyway. So if radius BD bisects chord CE, what is the measure of angle BEA? So we're looking for this angle right here. Okay, so let's draw out the triangle. I'm going to draw it out right here. Here's B, A, and E. They're telling us that we have a 58-degree measure up here. Remember, if the radius in the chord, if the radius bisects the chord, that means they're perpendicular to each other. So we have a 90-degree angle right here. What is the measure of angle BEA? Okay, and for this one, notice it's a fill in the blank on this quiz. Don't write degrees afterwards, just put in the actual measurement. So just put in the actual number. If you type in degrees afterwards, the computer is going to mark you wrong. Okay, Jacqueline. Okay, go ahead, Jacqueline. Great job. So 32 degrees is the answer here, but you guys will just write in 32 or whatever your question's asking you. You'll just put in the number. Don't write any words afterwards. Okay, great job. Okay, there is an extra credit that I want to give you guys.